Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new problem which says in a random experiment, a fair die is rolled until two fours are obtained in succession. Means we have to keep on rolling the dice till we get two consecutive fours. Okay? The probability that the experiment will end in the fifth throw of the dice is equal to. So on fifth throw we should end this experiment. So this means at fourth and fifth we should have 4. So 4 is yes. Now if you will assume 4 to be here, the experiment will end at this point. Okay, so here you cannot put 4, so no 4. Now this means it is mandatorily it is not 4. Now here we have to change, means at these two positions we should respond accordingly. This is fix, this is fix, and this is fix. Now no, 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 yes, yes, no, done. So these are the cases for the given condition. Okay. Now probability of getting 4 while throwing a dice is 1 by 6, as you know. Probability of not getting 4 is what? 1 minus 1 by 6, that is 5 by 6. Okay. Now let's write down the final required probability. So required probability is no 5 by 6, no 5 by 6, no 5 by 6, yes 1 by 6, 1 by 6. Okay, so the first part is clear. Now next we have no 5 by 6, yes 1 by 6, no 5 by 6, yes 1 by 6, yes 1 by 6. Okay, now in next part we have yes 1 by 6, no 5 by 6, no 5 by 6, yes 1 by 6, yes 1 by 6. So means here we have limited choice. Look at this, 5 by 6, 1 by oh, wait a moment, yes is 1 by 6, then 5 by 6, 5 by 6, 1 by 6, 1 by 6. Okay, now let's write down the final result. 5 into 5 into 5, 125. Then 5 into 5 is 25. Then 5 into 5 is 25. The base is same, 6 to the power 5. Okay, so it is 175 upon 6 to the power 5. Therefore the required probability is 175 by 6 to the power 5. I hope the idea is clear and you guys can handle similar situations. So see you guys in next session of MathFlix.